All right, builders, hackers, and creators, welcome. Think of this explainer as your official hackathon workshop. Our mission? To give you a killer toolkit packed with the latest tech. And with it, you're going to tackle one of the biggest challenges out there, fixing the internet's completely broken trust model. So yeah, let's dive right in. So there it is, your challenge if you choose to accept it. The internet, it's an amazing thing. But let's be honest, its foundation of trust is crumbling. We're going to break this huge, messy problem down into real, manageable pieces and hand you the building blocks you need to start coding a better, more trustworthy web. Okay, so these are the three big bosses for our hackathon. First up, the big blockchain paradox, right? How do you get total transparency without giving up all your privacy? Second, the absolute explosion of AI fakes, which makes it nearly impossible to know who or what is real. And third, in this decentralized world we're building, how on earth do you prove you're trustworthy? Here's our game plan. First, we'll get a handle on the core problem. Then, we're going to drop three super powerful building blocks into your toolkit: provable ID, fake detection, and reputation building. And at the end, we'll see how you can snap them all together to build a seriously cool, trust-native app. So let's kick things off with this fundamental conflict. The very thing that makes blockchain so amazing, this idea of complete transparency where every single transaction is public, is also its biggest privacy nightmare. It really is a double-edged sword. And look, this isn't some far-off future problem. This is happening right now. The research is clear. The more popular and complex dApps become, the worse this privacy crisis gets. The challenge for us as builders is obvious. We desperately need a way to prove things about ourselves without just handing over all of our data. Okay, tool number one for your kit: provable identity. The big idea here is all about solving that privacy paradox. How can you prove you're over 21 without showing your whole driver's license? Or prove you graduated from a university without showing the actual degree? Let's check it out. So the foundation for all of this is something called a decentralized identity, or DID. Just think of it like a universal username that you, and only you, actually control. It's not tied to Google, it's not tied to Meta, not to any government. It is your sovereign identity for the web. This is so cool. This slide shows the whole system working together. You've got an issuer, let's say it's your university. It gives you, the holder, a verifiable credential, which is just your digital diploma. Now, when some app, the verifier, needs to know if you graduated, you don't send them the diploma. No way. Instead, you just generate a special cryptographic proof that you have it. The verifier can check that proof is legit without ever seeing your name, your grades, or anything. Now, the magic behind this proof is called a zero-knowledge proof. For your hackathon project, you're probably going to choose between two types: snarks and starks. The main difference for you as a developer is the setup. The older snarks need this thing called a trusted setup to create the keys, which is kind of a security risk. But the newer starks, they're transparent. They don't need it. That is a massive advantage. Oh, and as a little bonus, they're also quantum resistant. And this right here, this is the classic engineering trade-off you're going to face. If you use the newer ZK Starks, generating that proof is way faster for your user. That's a huge one for user experience, right? But here's the catch. The proof file itself is a lot bigger. So for your project, you've got to ask yourself, what matters more? Is it speed or is it size? Okay, let's grab our second building block. This one builds right on top of our foundation. Now that we have a way to prove who we are, how do we make sure that the person on the other end of the line is a real, live human and not some super sophisticated AI deepfake? Well, you fight fire with fire. Or in this case, you fight AI with AI. The perfect tool for this job is a generative adversarial network, or a GAN. I absolutely love this concept. You basically have two AIs that are locked in an epic battle. On one side, you've got the generator. It's like a master art forger, trying to create perfect fakes. And on the other, you've got the discriminator, a brilliant detective whose only job is to spot those fakes. And as you can see right here, they're stuck in this constant loop. The generator makes a fake, the discriminator tries to bust it. The generator learns from its screw-ups and gets better. Then the discriminator learns from the new, better fakes, and it gets better too. You let this run for millions of rounds, and what you get at the end is an AI detective that is an absolute expert at spotting even the sneakiest fakes. So, does it actually work? Oh yeah. The research shows this AI detective can hit a 95% detection rate against deepfakes used for stuff like online payment fraud. That is a seriously powerful tool in the fight against deception. All right, let's get to the final block in our toolkit: building reputation. I mean, In a world with no central banks or credit agencies, how do you know who to trust? How do you even begin to build something like a credit score or a seller rating when identity itself is decentralized? Well, meet the Z-score. This is a really fascinating idea. It's basically a universal reputation score, kind of like a FICO score, but for the blockchain. And instead of digging through your bank records, it just analyzes a crypto wallet's public on-chain history to figure out how trustworthy it is. Now, the process looks pretty simple on the surface, but the real magic is in that AI analysis. First, it pulls in a wallet's public transaction history. Then, an AI model starts clustering the wallet's behavior. It looks at lending history, what tokens it holds, how often it transacts, and it groups it with similar wallets. Finally, based on the known risk of that whole cluster, it spits out a single reputation score. And here's the proof in the pudding. The AI actually learns to tell the difference between good and bad behavior. On the left, you can see it's grouped together all these wallets that have a history of getting liquidated on lending platforms. That's risky stuff. And on the right, it's grouped the wallets with a nice, clean history of borrowing and paying loans back. This is literally how it quantifies trust from raw data. It's amazing. Okay, team, we've got our 3 building blocks: provable identity, deception detection, and reputation. Now comes the best part of any hackathon, seeing how all the pieces snap together to build something truly awesome. So just imagine a decentralized lending app. A user shows up and logs in not with a username and password, but with their own sovereign decentralized ID. Boom, that's block 1. To stop fraud, the app does a quick liveness check, and our GAN detective from block 2 confirms it's a real person. And finally, to get the loan, the user doesn't have to upload their bank statements, they just present a proof of their high Z-score from block 3. It's secure, it's private, and it's trustworthy. So that's the toolkit. We've shown you how to combine sovereign identity, AI-powered fake detection, and on-chain reputation. And these aren't just theories on a whiteboard, these are powerful, real tools you can start building with today. We've given you the building blocks. Now it's your turn. Get coding. What will you build?